This is Geometry Lesson 3-2, Triangle Angle Sum. Our objective today is to use the fact that the sum of interior angles of a triangle sum to 180 degrees to solve problems. So the first thing I want to ask is why? Why do the sum of the interior angles of a triangle always add up to 180 degrees? And I'm curious to see what you guys would say when I ask that question, why. And I feel like most of you will say, well, because someone from 7th grade or 8th grade, someone told me that's the case, and I want to prove it to you now. So here's the notes that you'll write down. Why? Why do they add up to 180 degrees? So I'm going to start with a triangle. And let's make our triangle like maybe a little bit wonky here. I am going to prove to you by the end of this tiny little piece that if I add up measures A, B, and C, they will equal 180 degrees. And here's how I will do that. I'm going to draw an auxiliary line, which means it's an extra line that I don't really need. And that auxiliary line, I want to make it so that it is exactly parallel to this bottom line segment. So if I were to kind of extend this triangle line out a little bit, these two lines would be parallel. So I do a little mark on here saying these two lines are parallel. You're allowed to say, okay, you can draw a parallel line. We know how to do that by construction too, if we needed to. And oh, check this out. Did you know that if I were to, let me highlight this so you can see this a little better. Can you guys see in here that if I have this Z here, these inside armpits of the Z are called alternate interior angles, which means this angle and this angle have to be the same. They are congruent. We actually memorized these in our last unit, which means if I were to label this as maybe angle 1, I would say angle A and angle 1 are the same. So I'm going to go ahead and make a little bond. I'll say A and 1, these are the same angle. And, oh, check this out also. If I were to highlight over here, this Z over here, you can say that this Z and this armpit of the Z, these angles are also alternate interior angles. Therefore, these two angles are also congruent. I can say maybe that is called angle 2. And so I'll put a little line here to say, hey, these two angles are the same angle. And oh, check this out. This is a line, which means this is 180 degrees and this is 180 degrees. Therefore, this angle plus this angle plus this angle add up to 180 degrees. Angle 1, angle C, and angle 2 add up to 180 degrees. Well, if 1 is the same thing as A and 2 is the same thing as B, that means that A plus C, because this is 1 plus C, A plus C plus B is also 180 degrees. And there's my verbal and visual proof, although I would like you to maybe write this down a little bit more formally. This is my general overview. So here's what I'll say for my proof. And you guys will have to practice writing this down as well. So here's our proof. And what we do is we call these 2-column proofs because I have 2 columns. I have something that's called a statement, and I need some sort of justification or some sort of reason why I can say what I'm saying. Make sure every single statement has a reason behind it. So I will say that we'll label this line L and line M. So we'll say that line L and line L is parallel. Here's a symbol for parallel to line M. Why do we know that? Because I said so. Because we assumed it. So this is, we're just going to say that was given information to us. What else do we know? We know that angle A and angle 1 are the same. So we can say that angle A, this is how you say angle A, is congruent to angle 1. So this symbol right here, if you've never seen it before, is congruent. So maybe you have on the side an index of what these are saying. So this is the word. So I'll say this is our symbol, and this is the meaning of the symbol. This symbol means parallel. If I have a symbol that looks like this means angle. If I have a symbol that looks like an equal to sign with a little tilde above it, this is called congruent. Okay. Okay, so I'll say that angle 1 is congruent to angle A. Why do we know that? Because they're alternate interior angles. I'll say alternate interior angles. I'm just going to abbreviate. We also know that angle 2 and angle B are the same. So I'm going to say that angle B is congruent to angle 2. How do we know that? If it's the same reason above, you can just write alternate interior angles again. But if you want to be lazy like me, you just put double quotes. Double quotes is our way of saying, hey, just copy and paste the line up above here. Okay, we also happen to know that 1, C, and 2 add up to 180 degrees. I can say that the measure of angle 1 plus the measure of angle C plus the measure of angle 2 add up to 180 degrees. And this is something that's interesting. This is different than just saying angle 1 plus angle C plus angle 2. Angle 1 is a geometric entity. But if I say the measure of angle 1, this is now a mathematical identity. This is saying the number. Whenever I put an M out in front, it's now talking about the number. So if I put the measure of angle, this is the measure of the angle. And the really key part about this thing is it's now math. It's a number, right? So now I'm saying, hey, adding up these three numbers, the number adds up to 180 degrees. We'll check this out. I can now swap out the 1A. Why? Because I've said 1 is the same thing as A. So here comes the substitution. Oh, by the way, why can I say this? This is the definition of a line. I'll say definition of a line. And now I can swap out 1 and change this into a measure of angle A. Why am I allowed to do that? Again, A and 1 are the same, so A and 1 are the same. And I'm going to leave that old-fashioned measure of angle C here. That's not changing. And I'm going to add, okay, guess what measure of angle 2 is going to turn into? Well, 2 and B are the same thing, so I'm going to say that this is the measure of angle B. And that's going to be equal to 180 degrees. And this is, why were we able to do this? This was substitution. I'm running a little bit too close to each other. Substitution. And I'm done. Whenever you finish a proof, you're allowed to say quorum et determinum. You can say QED, which is Latin for, yeah, I've proven the thing that I'm trying to prove, which is kind of lame. Some people put like a little black box and say, I'm done. It's kind of like the mega period or an exclamation point. You can say boom, shakalaka boom at the very end. I don't really care. We're done with the proof. So there it is. So there is a formalized proof answering this question, why? The general answer to why was we linked it to a line that we do know, and then we are able to transform angles into other angles. All right, so now that we have that, I want to go through some examples with you guys. Let's do a nice, easy example that doesn't take too much work, too much thinking. So we'll say this is going to be example number 1. In example number 1, we'll just say find x. And we'll make a tiny little triangle. And we'll say this is like 137 degrees. We'll say this is 41 degrees, and this is x. So find x. There it is. Okay, good. How do you do example 2? I am totally joking, but to find x, you actually have to do the calculation. These three things should add up to 180 degrees, so we can make a formula and make this super formal if we want to. We can say 137 plus 41 plus x. Those three things should add up to 180 degrees, and you just solve. So I can say, okay, this is going to turn into, I'm combining my like terms, right? 137 plus 41 is 178. Oh, that's interesting. Plus x is equal to 180, and then I get rid of the 178 by subtracting on both sides. So I can say minus 178, minus 178, and then we get x is equal to 2. Cool. Let's try a slightly harder problem, one that you might encounter on the homework that looks tricky. Let's go ahead and say, really I shouldn't say find x, because then the answer is, haha, there it is. Maybe I'm going to cross it off and I'll say solve for x. So I'll start saying solve for x now. So solve for x. Let's make a harder triangle here. What if I do a triangle that looks like this? Boom, boom, boom. we'll just write in some random numbers. What if I put like a 7x plus 11? Let's put like a 2x, and let's put in, let's see, 9. I want to make the numbers come out nice, so this can be 169. So I want to say, what's 169? It's off by 7, I think. So if I say this is 7 plus a multiple of 9. So what if I do let's say that this is x minus 1. Would that work? X minus 1. I mean, I think this will work. Good. Okay, so solve for x. I had to make up a problem on the spot. So all three of these angles have to add up 280 degrees. So I'm going to say that 2x plus this 7x plus 11 plus this x minus 1, all three of these entities add up to 180 degrees. Okay, so how do I do this? Well, I'm going to combine my like terms, right? I have a 2x, a 7x, and an x, so that's technically a 1x, right? So 2 plus 7 is 9, plus 1 is 10, so I have a total of 10 x's over here. And then what about the constant terms? I have 11 minus 1, which is 10, so this is plus 10, and this is still all equal to 180. Okay, let's subtract 10 minus 10 minus 10, and I'm going to get 10x is equal to 170. And then finally, I need to divide by 10. Let's choose a different color though. Divide by 10, divide by 10, and x is equal to 17. I was confused there for a second. Cross off the zeros, right? 17 over 1 is 17. Done and done. It's a slightly harder problem. Let me do an even harder problem. Let's do example number 3. What would be a harder one? Oh, one way I could do this, what I would say is like, what is this angle right here? And you have to plug this number back in here, and you do 17 times. Oh, this angle is 34 because it was 2x. And since x is 17, 2 times 17 is 34. That would be a harder way to do that. I don't want to write down an example on how to do that. You guys know how to do that. Let me make one final hard example. How do I want to do that? Ooh, okay. Let me go ahead and do something that looks like this. I'm just going to kind of steal a homework problem and I'm going to modify it. So what if I have like a line down here? Make it straight, please. Thank you. What if I come up here and down there? And what if I come up here and down here? There's a bunch of ways you can do problems like this. I'm going to start making up some numbers. What if I put like, I'm just choosing random numbers. 85 degrees is this measure right here. What if I tell you that this measure right here is, I don't know, it looks about 120 to me, so I'm just going to say 120 degrees. What if I tell you that this angle right here is like 31 degrees? What if I tell you this angle right there, I don't know, to me it looks like a little bit less than 31, let's call it 29 degrees. I want to solve for this x. So I'll say solve for x. And by all means, I encourage you guys to try to pause the video now and try it on your own. But this is taking notes, and I'd rather get through this as fast as possible. So I'm going to jump right into it. But please do pause, think about the problem. You're going to be doing lots of thinking on the homework anyway. So how am I going to solve this problem? Well, I have two angles here. If I have two angles in any triangle, I can figure out the third angle because I know they all add up to 180 degrees. So let's go ahead and find this angle right here, which I'm going to call, I don't know, heart. How do I find heart? Well, I know that 31 degrees, I'm not going to put degrees, I'm just going to say 31 plus 120 plus heart add up to 180 degrees. So combining like terms, this is going to be 151 plus heart equal 180 degrees. And if I subtract 151 minus 151 minus 151, I'm going to get heart is equal to, what was that going to be, 29 degrees. So I know, oh, that just happens to be 29 degrees. I don't know. That was totally random. I just chose random numbers, guys. So we now know that you are 29. Okay, I also know the fact that a line here always adds up to 180 degrees, which means this plus this add up to 180 degrees. Let me make another equation over here that says 29 plus 85 plus, I need some unknown over here. Let's go ahead and call it star. So plus star, that all adds up to 180 degrees. So don't put the degree symbol because it'll mess me up. Adding some numbers together. 85 plus 29 is going to be, what is that? It's basically 30 plus 85. So 3 plus 8 is 11. So I'm thinking this is 114, I'm hoping. Plus star is equal to 180. It's early in the morning. I'm going to check my math. So 85 plus 29 on my calculator. I know what I'm doing. 114. And then finally, I'm going to subtract 114, subtract 114. I'm going to get star here by itself is equal to 66. Okay, so U are 66. And then finally, I can do this plus this equal 180 degrees. So let's go ahead and do this. We'll say that 66 plus 29 plus x, all three of those add up to 180 degrees. So again, I'll combine some terms. So 66 plus 29 is 95, I think. Is that right? I think so. So 95 plus x is now equal to 180. If I subtract 95, that was a terrible 5, subtract 95, that's going to be 85. X is equal to 85. Is that right? I think so. X is equal to 85, which just happened to be that number. Interesting. Yeah, I think that's the right answer. I just made up this problem from scratch, so I have no idea if I can actually check my work on the back. I'm just checking. If I made any mistake, by all means, log it on your extra credit tracker and let me know later. Those are the notes for today. And after taking these notes, make sure you are working on the homework. There should be 10 problems for homework 3-2 triangle angle sum. Thanks for watching, guys.